let sigma be the set of all bijections from 5 element set to 5 element set. So sigma is not a and b here. Remember that sigma is set of functions. That functions are also bijective functions from 5 element set to 5 element. You know, understanding 5 element set to 5 element is nothing but how many functions are there basically in general. If you look at 5 factorial functions, 5 factorial bijective functions are huge, right? You cannot take all of them into sigma to understand. So take at least 2 element set to 2 element set, so you can easily understand what's actually happening, what is actually happening. Okay, where id denotes the identity function. Everybody knows in the world what is identity function who are studying functions topic, right? But definition is given, just follow. Id of 1 is equal 1, id of 2 is equal to something like that. The elements are there, 2 elements are there. So now for all j, for all j you are going to apply this id of j is equal j. Let this a circle denote the composition on functions. You are very well aware of this composition function. For a string, any string, some w or x you take, that string is, let's say, is having the sequence of symbols x1 x2 so on till xn. Here this sequence belongs to sigma, some sigma power k, okay, sigma power n, some sigma power n. Here phi of x is some kind of notation which is nothing but, if you are doing the mapping on phi of x, that x1 x2 xn, all this composition is called as pi of x. So if you want to see pi of anybody, right, so that pi of x is nothing but x1, you need to do the composition, because they are going to use the definition in the language. Language is nothing but set of all the strings, nothing but set of all x, where that pi of x is id. So when you do the composition, result has to be id. So this is very important. The language is nothing but set of the strings. That string, when you map it, you should get id. Now let me help you with 2 element set how to understand, which is easily. So you have 2 element set, let's say 1 comma 2 to 1 comma 2. If you have 2 element set, there are how many functions that you can form? You know, first I'm trying to help you 1 2 1 2. The 1 maps to 1, 2 maps to 2. This is called as id. Like id of 1 is equal 1, id of 2 is equal to, this is id. So this is I'm calling as a function 1, because I have 2 functions here, let's say f1, and another function f2, 1 2 1 2, and 1 maps to 2, 2 maps to 1. This is f2. Only 2 functions are there in the world with 2 element set to 2 element set, and these 2 are bijective functions. How many? Bijective. We are talking about bijective only, not all the functions. Okay, all the functions could be different answer. Okay, so number of bijective functions are there, only 2 in the world, for from 2 element set to 2 element set. Now by taking these 2 functions, now you need to form a language. The language is nothing but, see here, x belongs to sigma star, x belongs to sigma star. Now that x, you may take epsilon, because why? The sigma power 0, if you take epsilon, phi of epsilon, you have nothing, right? So that epsilon is a special where you want to include or exclude. They did not mention anything about epsilon, so just aware of it. Epsilon may be there, may not be there. Okay, I mean, I'm keeping question mark, but just assume it's maybe there. That's fine by understanding the concept. Now which one you are going to include, f1 or f2? So f1 is by default is f1. If you put here, right, in place of x1, f1 itself id, right? Phi of f1 is id only. So next, and f1 one length, that is a one length string, 2 length string. f1 f2 you can't take, because f1 f2 is f2. If you see that f1 composition with f2, you will get f2, and so you can go for f1 f1. And another one f2, if you take composition with f2, you get f1 back. So whoever the composition results f1, that pi of x is equal f1, then you are going to take all such strings here. Now for this, how many states required? Just 2 states. One state, let's say initial state is the final state. If you don't want epsilon, still you can manage it. Okay, how do you manage it? So just keep f1 is someone else. Okay, now if I keep this f1, f1 is a final, and if I keep this f1, f1 is a final. So epsilon is your option. Okay, f1, let's say f2. Now initially I am assuming epsilon is, let's say, accepted. Now f1, if I read this f1 f2 just state names, but also we have the symbols here. F1 self loop, because any sequence of f1s you can come here, because id composed with id, you always get id. But f1 followed by f2 or only f2, you get f2. But f2 followed by again f2, you come back to id. But f2 followed by f1, that's id. Basically f2 followed by id, you will get f2 only. So f2 followed by f1, you will get f2 only. Okay, f2 followed by id, you will get f2. So this is your machine. Now how many states are there? Just two states. Why do you get two states? Because I have two functions. Why do you get why do I have two functions? Because for two element set to, from two element set to two element set, you have the only two bijective functions. If I have 5 element set to 5 element set, how many bijective functions are there? 5 factorial bijective functions are there. 5 factorial in the sense 5 multiply with 4 multiply with 3, 2, 1. Okay, that's equal to 120 bijective functions are there. So here 120. How many? 120 bijective functions. So the 120 states required to accept the language which has a set of strings. Each string, when you map, you will get id.